Hi, today you're going to be taking some notes off of this lecture on properties of water. So water is a molecule and it's composed of three atoms, oxygen and hydrogen. So here's your oxygen, and then you have two hydrogen. Water is polar, so each water molecule, the oxygen atom attracts more than its fair share of electrons. So the oxygen acts as a negative and the hydrogen acts as a positive, which causes the water to be polar. However, water is neutral and it doesn't have a charge. Hydrogen bonds exist between water molecules, formed between a highly electronegative atom of polar molecules and a hydrogen. One hydrogen bond is weak, but many are strong. So like if you try to lift something, with one paper clip versus if you have like 20 paper clips, it would be stronger. So the more you have, the better the strength. So when you have water molecules, negative oxygen end, so here's your oxygen end, of one why can't I say this? The negative oxygen end of one water molecule is attracted to these positive hydrogen ends. So they create a bond, and that's called a hydrogen bond. So what are the properties of water? Well, water has a boiling point of 100 degrees Celsius and freezes at 0 degrees Celsius. The boiling temperature of water decreases at higher elevations, so the lower the atmospheric pressure. So for instance, if you were going to cook an egg, it would take longer to boil at a higher temperature. That's why if you read like the back of baking boxes, like cake mix, it tells you a different cooking time for if you're in a higher elevation. So water properties, so you have cohesion, you have adhesion, you have high specific heat, a high heat of vaporization, and it's also less dense as a solid. So cohesion is the attraction between particles of the same substance. So water is attracted to itself, and what happens is you have a surface tension. So that's the measure of the strength of the water surface, and it produces like a film. That's why different insects can walk on water, and that's why you get, like, if you dropped a water on a piece of table, if you dropped water on a table, you would have like this little bubble form there. Adhesion is the attraction between two different substances. So water will make hydrogen bonds with other surfaces such as glass, soil, plant tissues, cotton. And what's really cool is you get this capillary action, and it pulls the water up. So that's why tall oak trees can get water from the roots all the way to the very ends of their branches. And if you go to the hospital, there's like, it kind of looks like this. There's this little tiny glass straw thing, and if you get your finger pricked, your blood goes right in there, and that's because of capillary action. It's kind of like it's sticking to the sides of that tube, and it sticks to itself to pull it up. So adhesion also causes water to stick together on spider webs. It forms little spheres, and it holds on to plant leaves. High specific heat, the amount of heat needed to raise or lower 1 gram of substance 1 degree Celsius. So that's what that means. Water resists temperature change, both for heating and cooling. Water can absorb and release large amounts of heat energy with little change in actual temperature. This is why the ocean is very important to our global climate, because it will suck up extra heat from the earth and try to stabilize our earth temperature. So high heat of vaporization, the amount of energy to convert 1 gram or substance from a liquid to a gas. So in order for water to evaporate, those hydrogen bonds that we just talked about must be broken. As water evaporates, it removes a lot of heat with it. High heat of vaporization continued. So water's heat of vaporization is 540 calories per gram. And in order for water to evaporate, each gram must gain 540 calories. So it's, when they figure out calories of food, they actually burn it, and then the amount of heat given off on that tells you the amount of calories that item has. That's why, like, Doritos burn a lot hotter than, say, an apple would. As water evaporates, it removes a lot of heat with it. So a cooling effect. That's why when you exercise and you sweat, you get colder. That's why that's important. Water vapor forms a kind of global blanket. We're going to get into this more later on, but basically it helps keeps the earth warm. Water vapor is actually a type of greenhouse gas, a natural greenhouse gas. Heat radiation from the sun warms the surface of the earth, so it's absorbed and held by this vapor. Water's less dense as a solid, so ice is less dense. It will float. Liquid water has hydrogen bonds that are constantly being broken and reformed. Frozen water forms like a crystal, this word is lattice, where the molecules are set to fixed distances. So if you see here, which is ice and which is water. So look at this picture. So which one's a solid, which one's a liquid? Which one's more structured versus which one's less structured? So if you look here, you have water, which constantly forms bonds and breaks bonds, and then you have ice. So homeostasis is the ability to maintain a steady state. So water is very important to this process to keep homeostasis happening on Earth, because it's a good insulator. It resists temperature changes. It's a universal solvent. It's a coolant. And the ice protects against temperature extremes. Sometimes in areas where they're going to get a frost and it can hurt plants, people will spray their crops with water so the water will freeze, and that will save it from the frost. So solutions and suspensions. Water usually is part of a mixture. So there's two types of mixtures. There's a solution and there's a suspension. A solution is ionic compounds dispersed as ions in water. They're evenly distributed. A solute is the substance being dissolved, and a solvent is what is the solute substance into which the solute dissolves. So, okay. Water, solvent, salt in the water would be the solute, okay? Water is the solvent, salt is the solute, what's being dissolved, okay? Suspensions are substances that don't dissolve but separate into tiny pieces. Water keeps the pieces suspended so they don't settle out. Acids and bases and pH. So this is important too. One water molecule in 550 million naturally dissociates, so that means it comes apart into a hydrogen ion and hydroxide ion, so H and OH. Because of this, with the pH scale, it basically tells you how much hydrogens you have in there. So if something's 0 to 7, it's an acid, and if it's 7 to 14, it's a base. So basically, what I want you to know for the pH scale is obviously what the scale is, that it's really the amount of hydrogen in it, or hydroxides for 7 to 14, but just kind of have an understanding of the scale, that if you have a 1 to 3 pH, it's a very, very strong acid. So your acids go from 0 to almost 7, and then your bases go from a little above 7 to 14. If you have 11 to 14, that's a very, very strong base. So like an oven cleaner, that would eat away at your skin. So the last thing is water acts as a buffer. So weak acids or bases that react with strong acids or bases to prevent sharp, sudden changes in pH. So it keeps our bodies safe because we have water in them. And then, if we drink something that's acidic, or we're not drinking enough water, it keeps us, it keeps our bodies stable. So we have we're made up of a good deal of water, a good amount of water. So that's why it's important to drink a lot of water. And like, if you get headaches, that might be one of the first things you want to do, is drink a lot of water, because you could be dehydrated. Okay, so make sure you fill out your Cornell notes when you're going through this, and go back, review, stop the video. Have a great day.